Okay, let's take a quick look at the rooks problem in this week's homework. Let's start out by setting the number of simulations. I'll just do a short number, 10, and a results vector where I can store the results of the simulation. So I'll let that be a vector, which is the repetition of 0 n sim times. And now we've got to think about how we're going to pick where these rooks are going to come from. So the way that I'm going to do it is think of the 8 by 8 board, the 64 spaces, as a grid of tuples, so 1 comma 1, 1 comma 2, and so on. So I'll think of picking a rook as picking a row and a column. So let's first develop a rows vector. So the rows vector would be, let's go ahead and let it be the repetition of 1 through 8, 8 times. So what does that give us? What it gives us is something that looks like this over here, 1 through 8, 8 times. So there'd be 64 groups of the sequence 1 through 8. So that's the way we can get, say, the x value of the tuples. Now we have to be a little bit more creative about the columns. So the columns, of course, we don't want to be the same as the rows. We'd like, for instance, for this whole first set of 1 through 8 in the rows to be paired with all ones in the column vector. So the way you can get that done, there's a number of ways you can do that, but one way you can do that is to repeat the digits 1 through 8, but repeat them each 8 at a time. So the way that you say that is by putting in a vector of repetitions where we repeat 8 times. So what the second argument tells us is to take this 1 through 8 and each incrementally to repeat this many times. So when you give a vector argument over here, what it does is say how many times to repeat every one of these elements. Since there's 8 elements here, you want to have 8 values in the vector of repetitions. So now if we take a look at rows and columns, then we can see that indeed we've got a set of rows 1 through 8 that are all paired with the column 1, and then a set of rows 1 through 8 that are all paired with the column 2, and so on and so forth. So it seems like that's mimicking the tuple definition, I guess, of positions on an 8 by 8 chessboard. Okay, so at this point I'm going to go ahead and start my for loop. So I'll let I range from 1 to the number of simulations, and the first thing we're going to do is we're going to sample 4 locations for the 4 rooks. So location, I guess, what we want is to pick a location in each one of these strings of rows and columns. And since there's 64 locations in each of these 2 strings, what I'm going to do is go ahead and sample 1 through 64 to tell me what location in the rows vector and columns vector that I want to actually extract as my location for the rooks. So here we go. I'll go ahead and say let location be a sample from 1 to 64. I'm going to pick 4 of those and let replace be equal to false. And what I'm going to do at this point is just simply print the rows vector at the locations that are sampled. And by doing square brackets, that'll tell me to pick those locations in the row vector, and the columns vector at the locations that I've picked. So I'll have to print both of those just to see if this thing is working. And oops, I'll go ahead and just run it for the time being. So I can see that what's going on is it's printing both a set of 4 row locations and a set of 4 column locations. It might be kind of interesting to see what the locations vector is saying to do. So in each one of these cases, what it's saying is go to the 46th element in the rows vector and the columns vector and pick out that number. Go to the 61st element in the rows and columns vector and pick those elements. The 41st location would be 1, 6, and the second location is 2, 1. So it does seem like it's working all right. So let's think about now what we want to test. So we know that we want the rows locations and the columns. We want both of those to be, in this case, unique, 4 unique numbers. So if we get 4 unique numbers for the rows and 4 unique numbers for the columns, then that means that you have no rooks that can capture one another. So let's go ahead and see if we can test that. So really what we want to test is we want to test if the length of the unique elements in the rows at the locations chosen. We want to test to see if that's equal to 4. So a double equal sign is a logical argument in R, so we'll use double equal sign equal to 4. But we also want the same to be true for the column locations, so let's see what happens there. So change this to columns, and I think I'll just hit a carriage return here so we can see it all. Okay, so we want the length unique of the row locations and the length unique of the column locations to be tested to see if they're both equal to 4, and if they are, then we start an open bracket and evaluate an argument if this whole and statement is true. And what we really want to do is just keep track of how many times that happens. So what we'll do is in the results vector in the ith position, we'll store a 1. And that should keep track of how things work. Okay, so let's go ahead and down our simulations, let's say to 5, and let's take a look at printing the rows location and printing the column locations, and then printing the results vector, and running it all. And I'm missing something. Print error in row location. Row location. Oh, it's rows location. There it is. Okay, run it now. Column location. It's columns. Okay, running it now. Okay, now we're looking a little bit better. It looks like rows and columns have been identified here, and since all of these are, well, 2 of these are the same, 6 and 6, so it looks like the row locations are 2 identical, so we don't get a unique element there. But it appears at the end that the third test actually produced one where all of them were unique. Let's go there, 4, 3, 2, 6, 7, 8, 1, 4. And indeed, it looks like that's a case where all of them are unique. So 1 was placed in the results vector because none of these 4 rooks can capture one another. In this element, for example, these 2 rooks have both a column location of 7, so they can capture, so a 0 is left in the results vector. Feels like it's working all right. Let's try it maybe 10 times and see what happens. And here I can see that, well, at least the last one, we got unique elements, and 8, 1, 6, 7, 2, 3, 7, 8 seems to be correct. Okay, at this point I feel fairly confident that it's running all right, so I'll go ahead and do a table of results and up the number of simulations, say to 1,000, and run it and see what I'm getting. Let's go ahead and proportion out the table of results and run it again. And there I'm getting about 17.5, 16.9, 18.3, 18.1% of the time we're getting favorable outcomes. Let's go ahead and run it a few more times. 19.05, 18.69, 18.14. So at this point, rather than waste your time on the video, I'll just say you'd probably want to up the number of simulations 1 power 10 and see if you're getting some agreement between the 2 results when you run it twice. But it looks like we've developed some sort of a way now, or I guess an acceptable program for modeling the situation.